Okay, well, we have with, which is simply to find the product of these two rational expressions. Okay, and it's really pretty simple. You just factor everything, then divide out whatever's in common between the numerator and the denominator. So as long as you know how to factor, it'll be easy to do this. So this one factors into x plus 1 times x plus 7. And if you're using a trick, you know, that has this thing with numbers here, numbers there, here, here. Okay, but you should always be able to fall back on just figuring out what the factors of 7 are and so forth, and do some trial and error on these things to locate the factors. If you got a lot of factors, that trick is probably going to be okay. But it takes you a step away from what's really going on. It takes you a step away from the distributive law. It's hard to connect the distributive law with that trick, okay? And as I've said, unless you understand how that trick is connected to the distributive law, I don't mean just understand that, yeah, it gets you the right answer, then you're missing some insight, okay? So if you got a really tough one and you can't find the factors no matter how, then try the trick, okay? And I'm saying you just try, well, I'll show you in a minute. X squared minus 1, that's a special product. That's one that should immediately recognize as a difference of two squares. So you got x minus 1 times x plus 1. Okay. Now here, if we want to factor this, and I did screw up, I had a minus in front of that 3, but we corrected that. And it made it a lot nicer. What do you see? You got to have x along with something and x along with something. Okay. You got to have an x in this one and an x in this one, because the distributive law will then give you x squared, right? And you got to have a 3 and a 1 here, because those are the only two integers that multiply out to 3. So the distributive law says, well, you got to do this times this, and then this times this, and this times this, and this times this. Okay. The only thing you got to do now is figure out the signs in these things. Is it plus 3 and minus 1? Well, it can't be, because then a plus and a minus would add up to a negative. Okay. So they either got to both be plus or both be minus. Now, if they're both plus, let's try that. The distributive law says it's x times x plus 1, right? That would give an x squared plus 3x. And then 3 times x plus 1 would give you 3x plus 3. So you'd have a 3x from here, and a 3 and an x from here would give you a 4x. Well, that's great, but you want a negative 4x. Now, probably you would see this immediately, that you're going to have negatives here. Since the signs of these things have to be the same and that multiply out to 3, you see that they both better be negative, because the signs of these things are going to determine the sign of this. Well, I'm going to try to think it through that way. And if necessary, go back when we were doing these things originally, the original factoring of trinomials with leading coefficient 1. We broke it down, did a lot of stuff. Now, if you immediately went to the shortcut and didn't see what was going on with all that stuff, you're missing the connection, okay? Anyhow, this will then be over x plus 1 squared. Because again, this is a special product. This is an application of this special product, and this is an application of this special product. And you should make sure you understand why, because special products can be very handy. when I'm doing a test and I don't want to make it too long, I'll put a fair number of special products in there because you ought to be able to factor those really quickly. Okay? Well, anyhow, you have this. Well, that gives you what? Makes sense? Okay. Now, this x plus one will divide this x plus one. You have a factor of the denominator and a factor of the numerator. You couldn't cancel the x with the x because x isn't a factor. It's not something that multiplies the whole denominator, but x plus one is. And x plus one is a factor of the numerator. So if you want to do that cancellation thing, you can just cancel these. That's legal. Okay. Well, then you have an x minus one and an x minus one. This will divide into this, and that just gives you one, and everything is multiplied by one because this is a factor of the denominator, and this is a factor of the numerator. You can't cross things out unless they're factors of the numerator and denominator. Okay. And if you wanted to write the denominator as x plus one times x plus one, that's fine. But since I have the special product that gave me a perfect square and I didn't need to divide any of these, either of these x plus ones into anything else, it works. Okay, now let me take a quick look, because I'm not sure that's what everybody got, and it's everybody got the same. Okay, that is a 7. Okay, you're good. It would have been very unusual for everybody to get the right answer. And the right answer to differ from something I did right. Okay. And what I wasn't seeing, didn't look closely enough to see the x plus 7 in your solution. But of course, the x plus 7 does come from this factor here. It has to be there because nothing else divides it. Okay, well, you see, this is pretty simple if you can just factor. Okay, it isn't bad. What if we wanted to divide this by this? Then let's just I'm going to run it this way. What if you wanted this big old complex fraction? Okay, wanted to simplify this. Well, I'd have to write this kind of small, but I think you'll see what's going on. First of all, this is x squared plus 8x plus 7 over x squared minus 1 divided by this, because if this is a numerator of a complex fraction, this is a denominator. You divide the numerator by the denominator. And that gives us x squared minus 4x plus 3 over x squared plus 2x plus 1. Now, I've written that kind of small, but you see that this just becomes this thing you're dividing by. I've got this in the way, but I don't want to erase it. So I'm going to come down here, and this equals x squared plus 8x plus 7 over x squared minus 1 multiplied by, because when you divide by a fraction, you multiply by the reciprocal, multiplied by x squared plus 2x plus 1 divided by x squared minus 4x plus 3. Now, do recommend that you write the divided by step out here. But you can see that if I got this over this, if I flip the denominator and multiply it, the flipped denominator is going to be this. Can you see that? We just flip the one with the negative 4x on it's in the numerator of this expression. Now it's in the denominator, right? And the one with the 2x on it is in the denominator. Now it's in the numerator. Well, having done that, we can factor. And it's all very similar. Now, we know how to factor these things, so I'm just writing them down. And now we see that we have an x plus 1 that'll divide one of these x plus 1s. So we cross out this factor of the denominator and this factor of the numerator. And now this equals we got 2x minus 1s down here, so we'll write that as x minus 1 squared and so forth. And you'll understand the details. It's just that we see two things here. One, this complex fraction, a fraction divided by a fraction. We just write it as this fraction here divided by this fraction. And then we know when you divide by a fraction, you're multiplying by the reciprocal. So there it is. And then it's just a straightforward matter of factoring and dividing out common factors. Okay? So it's not at all any more difficult than what we did there, as long as you remember you're going to have to divide by the reciprocal. Okay, or you have to multiply by the reciprocal. All right, now multiplying and dividing, as long as you can factor, multiplying and dividing rational expressions is pretty simple. Factoring is the only real hang up if you practice it and know the order in which things happen. Adding fractions, if you remember from the very first assignments, you got to find a least common denominator, right? So for example, let me ask you to work this one out. I don't work with 16. We'll go just 3 out of 4. Okay. 7/6 plus 3/4. Okay, everybody got the right common denominator. Somebody misread the plus for multiplication, but went ahead and found the common denominator anyway. So I exaggerated the plus, but it's kind of a little sense of humor, very little. Okay. So common denominator is 12, we see that. Okay, and we put everything over 12, we get 14 over 12 and 9 over 12, so it's going to be 23 over 12. So that's what you got. I didn't look that closely. Yeah, I just looked to see if you were finding the common denominator. Then I know I could trust you to do it right. Okay. Now I'm going to do this a little more theoretically. Okay. How do you know to use 12 and not 24? Because of course 6 times 4 is 24, and that's a perfectly good common denominator, right? But the numbers are smaller if you use 12. Okay, well, you can just look at 4 and 6 and see that 12 is the smallest number that's the multiple. Okay. but you can't always just look at it. So I'm gonna say this, okay, common denominator. 6 equals 2 times 3, 4 equals 2 times 2. Okay? The least common denominator must include 2 times 3 as well as 2 times 2. Okay? Now, what's the smallest number that includes both this and this? It could be 2 times 3 times 2 times 2. That certainly includes this, and it includes this. I say that this is sufficient because this contains 2 times 3, right? Does it also contain 2 times 2? Well, yeah. Okay, well, here's your 2 times 2. Kind of do it like this. Okay? There's your 2 times 2. Just because this 2 is doing double duty as part of 2 times 3 and 2 times 2 doesn't mean that this thing can't contain both this and this. Okay? Because this will divide this. 2 times 2 into 2 times 3 times 2, it's going to leave you 3, right? And 2 times 3 divided into this is going to divide out the 2 and the 3 and leave you 2. Okay. Now, when you did fractions, I believe I showed you about finding the product of numbers such that the numbers were all prime. In other words, you start with 6, you divide by 2, you get 3, that's prime. If your number was 12, well, you divide maybe by 2, you get 6. Okay, then divide by 3, you get 2, or divide by 2 and then get 3. Usually divide by the smallest prime first. And that gives you what's called the prime factorization. And so you might want to review that. It could come up. I mean, it's an important thing to remember. It's going to save you a lot of trouble. Well, anyhow, that's just a quick review of what we should know about adding fractions. Now, everybody did real well. They found the common denominator. If the numbers had been bigger and more complicated, you would have had to start breaking it down into primes. Okay. And then figuring out what product of prime numbers you need to cover both the 6 and the 4. Okay. Okay, well, let's go back to our favorite numbers here, our favorite expressions. We have this. We've got to find the common denominator. Well, first of all, really what we want to do first is factor, as we could have done here, okay? We factored 6 into 2 times 3, we factored 4 into 2 times 2. And really, first we would factor both the numerator and denominator and simplify these. Okay, because we see from over here that this one simplifies. It is just x plus 7 over x minus 1. But that's not going to illustrate what I want it to illustrate. So normally we would simplify both of these, break them into their factors. Okay, what's our least common denominator going to be? We take the factors and see just what the minimum expression is that contains both of these. Okay, both this and this, right? Okay. Now, I'm just following the same procedure I did over here, except with symbols. Okay, so here we factored the common denominators and we're trying to find a common denominator, okay? You said that common denominator would be this. This is a common denominator. That would work. That would be just fine, okay? But even finer, what is sufficient? Analogous to what we did over here. There's something we could leave out and still get an expression that contains both this and this. Okay. See if you can figure out what that might be. Let you think about it for a minute. Giving you a hint. If it's got both this and this, then it's got to have this, right? So you got to have the x minus 1 times x plus 1. Is that enough to contain this? Does this have anything that this doesn't? If so, put it in there. Okay, half the class said x minus 1 times x plus 1 squared. The other half said x minus 1 times x plus 1 times x plus 1. Okay, now going by this process, everybody saw it, and both answers are correct. Okay, but I'm going to say, okay, again, we gotta have something that contains both this and this. What contains this? Well, anything that contains this, because this is the same as this, right? So clearly this contains this, and I don't need any more to contain this. But I don't have enough to get this. I've got an x plus one, but I need two of them. So again, what does this have that this doesn't? An extra x plus one. Now, if this was the 48th power of x plus one, I wouldn't expect you to write out 48 x plus ones here. You would use the exponents, right? It helps to see both forms of this. Because one thing that'll happen is somebody will have an x plus one in the denominator. Well, somebody will do something like this. Okay, here's x plus one, here's x plus one. Just cross them both out and get rid of them. Well, no, this really means x plus one times x plus one. And then point at something nobody will see on the screen. Let's look again. One reason for writing out all the x plus ones is that you can see clearly that you can't take this x plus one and cross out this x plus one and just get rid of both terms. Okay? Because this x plus one really means two x plus ones multiplied. And you can only divide this into one of them, and you're going to have the other one left. Now, the rule is you cross this out, then you cross out the two, and you put a one. A lot of people don't understand what they're doing when they do that. They just do it by rote. And for that reason, I like to write out all the x plus ones. But as I said, if you got an x plus one to the 48th power, well, you could write that as x plus one times x plus one to the 47th power. And then this x plus one would divide this, and you see that you got the x plus one to the 47th power. Okay. Okay, well, anyhow, everybody here did really well with this. And what I'm seeing in the pattern for the distance students, if anybody, if any of the distance students are paying any attention to these classes, the distance students seem to be pretty good, at least from the tests that I've gotten from them, pretty good with exponents. Okay. So I think they're likely to understand this. Some people in both classes need a little more work on using the distributive law. Because a lot of people still think that x plus one quantity squared is x squared plus one squared. Stuff like that. So we got to be careful of that. And people in both classes are doing that. Most of the people who are here today, because we only have half the class here right now, are doing it correctly. So that's not something y'all need necessarily here, but I'm seeing some people that need extra work on using the distributive law when it's required. Okay, well, okay, now having done that, what in the world do we do next? Okay. Oh, I think it's still all this for good. Okay. Now I'm going to go ahead and do this, and I'm going to factor it, okay? And I'm going to pretend that I forgot to simplify after I factor it, because if I simplify after factoring, common denominator becomes a little simpler, okay? And then I'll do it again that way, so you see every possibility. Okay, you got x squared plus 8x plus 7 over x squared minus 1 multiplied by x squared minus 4x plus 3 divided by x plus 1 times x plus 1. Well, no, Let me just write out the original expression. I got ahead of myself and started a factor, but I want to do that in the next step. That's the original problem. So you can say, okay, that's x plus 1 times x plus 7 times x minus 3 times x minus 1. And this is x minus 1 times x plus 1 times x plus 1 times x plus 1, which could be written out x plus 1 cubed. But for now, I would write them all out and then write it with the cube so you see how everything divides out according to the rules for exponents. Okay. Well, let's say I didn't see that x plus 1 can be divided out here and x minus 1 can be divided out here. And then I need to remember that I'm doing addition and not multiplication. So I need a plus sign between this and this, because the next step wasn't going to make any sense. It should be plus x minus 3, x minus 1, x plus 1 times x plus 1. Now there is one simplification. This doesn't simplify. This does. You get x plus 7 over x minus 1. Okay. Let's pretend we didn't see if these x plus 1s will divide out. Common denominator is this. Okay, so how are we going to get common denominator? Well, we're going to write this out in some detail as x plus 1 times x plus 7 over x minus 1 times x plus 1. Give ourselves a little room. Then we're going to write x minus 3 times x minus 1 over x plus 1 times x plus 1. The denominators are different. These cannot be added the way they are. So what do I have to do? I have to multiply this one by, well, I'm going to need another x plus 1 in the denominator. I can't just multiply the denominator by x plus 1. That would change the value of the expression. But I can multiply by x plus 1 over x plus 1, which is just like multiplying by 1. So I haven't changed the value. If x is 372, and I substitute that into just this expression here, you're going to get an answer, okay? If I multiply by what I get when I substitute 372 in here, well, that's just going to be 373 over 373. It's not going to change the value of what I have here. Does that make sense? Okay. And then here we multiply by x minus 1 over x minus 1. So that again, I have x minus 1 in the denominator and a couple of x plus 1s in the numerator. Okay, so this equals this plus this all over. Yes. Now, I might see, well, I've got an x plus 1 here and an x plus 1 here. Can I cross that one out? No. Because I've got this over here and the x plus 1 doesn't divide it. X plus 1 is a factor of the denominator, but it's not a factor of the numerator because even though it's a factor of the first term in the numerator, it's not a factor of the second. Okay? So now this gets complicated. Multiply out the numerator. And then add, simplify the numerator. We're going to get 2x cubed plus a bunch of other stuff. It ends up with -3 and 7. With some x squareds and some x's in the middle. Okay. As you know, that can be hard to factor. Turns out it would factor, but you probably wouldn't find it. But in general, if you do this sort of thing, well, here we put it all over common denominator. And now we've got something where we've got to factor the numerator to see if any factor of the numerator matches any of the factors of the denominator. I said that kind of fast. Makes sense? Okay. So that gets to be a mess. And we're not going to deal with it. Okay. We're going to do it the way we should have in the first place. But I wanted to illustrate how we can find a common denominator. And sometimes you will end up with something like that down here that you're going to have to try to find a factor of, do a long division, and all that stuff. Okay. I'm probably not going to put anything that challenging in the final of this course. Something you would have to do in pre-calculus, and you have plenty of time to take what you're learning here to do that just a little bit of extra. As you've already seen it, it should work for you when you get there. Okay, so let's try this the right way. I have a dot here. Actually, there's a very small plus sign. Okay. Okay. Well, that equals okay. Now that 3 might be hard to read. Not very well. Well, I can divide out the x plus 1 here. So I've got x plus 7 over x minus 1 added to x plus 3 times x minus 1 over x plus 1 times x plus 1. Okay. Well, the common denominator that includes this one. But it's also got to include this one, so anything this one has that this one doesn't better get thrown in there. So there it is. Well, I'm denominator, now we continue on. So we get just rewritten what we have, but now we're gonna do what's necessary to get the common denominator. Well, no, we're not gonna do it, you are. And then we'll see how you do with it, okay? I've been talking a lot here, let's see if we draw it together and see if we can find our final expression. Okay, pretty sure everybody's got it. One person's still writing a little bit on this last one, but I'm sure that's gonna come out correct. Okay, so I'm gonna have to multiply by, first thing I need, so I need an x plus one and another x plus one, and this is denominator, so there it is. And over here, I need just an x minus one, because the common denominator has to have an x minus one as well as two x plus one. So I can do that. I'm going to put parentheses here, so we don't confuse terms. But now I see that my denominators are going to match. Of course, I can't stop there. I've got to have numerators that equal the denominators. And now, no matter what number I put in for x, this x plus 7 over x minus 1 is going to give me the same thing as x plus 7 over x minus 1 times this thing, because this thing has the same numerator as denominator. So I'm just going to be multiplying by 1. Okay. And I have an x minus 1 here. All right, well, how about if some of you, those of you who are on this half of the room, multiply out this numerator, and those of you who are on this half, multiply out the denominator. So there are going to be hordes of people doing each of these. I should clarify, I didn't do this stuff, but we have x plus 7 times x plus 1 times x plus 1 plus x plus 3 times x minus 1 times x minus 1. And that should have been x minus 3 all along, because I had x squared minus 4x plus 3. So I hope those of you who are watching have been crazy with that. It should be x minus 3. So it's not going to work out if you got the x plus 3. Then that's all over x minus 1. That's x plus 1 times x plus 1. So somebody then, in simplifying this, had this expression. And instead of multiplying out the numerator, divided out the x plus 1, which is perfectly valid the way this is written. But when it's added, we can't divide either the x plus 1s into these x plus 1s. Because x plus 1 certainly is a factor of the denominator. It's not a factor of the numerator because this part of the numerator doesn't contain x plus 1 as a factor. Okay. So now we've got to multiply out 3 binomials. And we've got to do that because, as I said, people aren't totally comfortable with the distributive law, and some people aren't even using the distributive law when it's necessary. So we really want to practice that a little bit and also see where this leads us for the current problem. Okay, now this is about as challenging as we're going to get with the distributive law in this course. Okay, it gets a little more challenging sometimes in recalculus course, but just trying to get enough intermediate algebra. Everybody can then do the pre-calculus course along with the co-reps course. Okay. Okay, so what I'm going to do is I'm going to multiply this first parameter. It's x plus 7 times x minus x plus 1 times x plus 1. Now, usually I choose to multiply the x plus 1 by the x plus 1 because that's just x plus 1 squared, and I could use a special product. It would be x squared plus 2x plus 1, very easy. But I'm going to do it the harder way because it's more general. Okay, so what I have to do is I have to choose 2 of these to multiply. So I'm going to choose to group them like this. And that's going to be x squared plus 7x plus 8x 7 multiplied by x plus 1. Now, how do I multiply this out? Well, by the distributive law, that's x squared times x plus 1 plus 8x times x plus 1 plus 7 times x plus 1. It's not at all difficult. You just have to use 2 steps. You can easily multiply 2 binomials. Everybody knows how to do that. And then you're going to have a trinomial you can multiply by the binomial. Now, people, use little arrows like this, not arrows, but little arcs. Okay, that gets out of hand if you got long expressions. Okay, so you want to be able to write it out literally using the distributive law. Okay, and I will ask on the exam. If I don't ask, you can do anything you want. Okay, as long as you get it right. But I very likely will have a problem in there. It says, show me explicitly how you use distributive law with no arcs and arrows. Okay. It's all very easy now. You just got to do it right. So my chances are not good. But anyhow, I think that's what we had, right? I'll put parentheses around these just emphasize that this came from this product, this came from this product, this came from this product. Well, then that's going to be x cubed. It's the only x cubed we got. See, we've got x squared and 8x squared. Which is 9x squared. Seems like I'd be missing something. Yeah, that's right. Okay. Or I was missing something. I don't think I am. And then x's, I've got 15x, 8x, 7x, and then I've got 7. Okay. Now, I'm going to do it quickly just so I don't have to use all the board space. I'll do the same thing I did before. I chose to multiply the X minus ones together, and these use the special product, but it's easy to multiply either way, okay? And then it's gonna be X times this, well, X times X squared gives me X cubed. Don't do the shortcut, write out the intermediate step like that. Okay? It'd be X times all this minus 3 times all this, right? Okay, when I do that, the X times X squared is gonna give me X cubed. X times 2X is gonna give me 2X squared. But then I'll have a minus 3 times X squared, which is minus 3X squared, so that's minus 5X squared. Okay? And then X times 1 is X. Negative 3 times 2X is 6X. That's going to give me 7X. And then it's going to be minus 3, I think. I know what to look at. I know where to look. Maybe I looked right, maybe I didn't. So you can do it yourself and see if I did it right, and then just laugh at me if you find out that. Okay, I don't mind. Okay. Then our final expression he's out of time. It's going to be X cubed plus 9X squared plus 15X plus 7 plus X cubed minus 5X squared plus 7X minus 3, which equals 2X cubed plus 4X squared plus 22X plus 4. So that this here equals 2X cubed plus 4X squared plus 22X plus 4. All divided by the common denominator. Okay, so we had to do some work to get the numerator. Normally we would do that off to the side, and then down below this, we'd write this expression. Okay. And then we'd attempt to factor this. Well, if X minus 1 is a factor of this, X minus 1 is 0 when X equals 1, right? If this has X minus 1 as a factor, it's also going to be 0 when X equals 1. And if X equals 1, then I need 0 because everything's positive. Yeah. If this is 0, then X is negative 1. If X plus 1 is a factor of this, then negative 1 will also be 0 of this. And it's not so. You get a negative 2 and a negative 22, which is negative 44, and a plus 1, which is 0. That's a trick you'll probably deal with in pre-calculus, so I'm not going to say any more about it. But I can see just by checking the numbers that make the denominator 0. And the only way the denominator is going to be 0 is either if X equals 1, which makes this 0, or negative 1, right? Any number except 1 or negative 1 is not going to make this. It's going to give me 3 different numbers here. None of them are 0, so this can't be 0. Okay, so I know what the zeros in the denominator are, and I check with the numerator, and none of them makes the numerator 0. So there's no common factor, and that could be our final result. Sometimes you might want to factor this way if you could, but you probably can't. Okay, so I'm not going to test you over the last little bit that I said, but you should be able to do this whole process. Okay, and if you can, then that's kind of one of the big deals. Shows that you know some intermediate algebra. Okay, very good. Y'all do well.